read. These were your key concept questions, and you got through most of the key terms. I'm going to go over some of them, but not all of them. We just talked a little bit, how do weathering and erosion affect Earth's surface? What are the causes of mechanical and chemical weathering? And what determines how fast weathering occurs? So let's start here. Weathering, which we've already defined today, the forces of weather that break down rocks. So we've discussed quite a few of those, and we'll go over a few more specifically, but weathering, that's pretty easy. Then, as you're watching this, you might think, well, isn't that the same as erosion? And technically, erosion is when the particles are moved away to another place. So weathering, they get broken down. Erosion, they get removed or moved to another place. So in erosion, the soils, the rock, whatever, is moved away. And then the final thing on this first part that's important, uniformitarianism. What a big, huge word. Who knows what uniformitarianism is? So it seems a little confusing at first, but yes, uniformitarianism. Uniform means to be the same. And uniformitarianism is that processes like weathering and erosion, they affect the Earth today, but we need to assume they also acted in the past. So then when we look at rock types, when we look at sedimentary rock, when we look at erosion, well, we can look at Mars and see evidence of erosion. And because we can assume with uniformitarianism that these same processes have always occurred, then we can say, oh, it looks like there was probably a flood here in the past. Or it looks like this area is a desert now but used to be a beach, because we can assume that those same forces are happening then that happen now. Because if they didn't happen before, then we can't really make any assumptions about the past. Does that make sense? All right, let's look at what we have next here. Oops. Okay, so weathering changes the Earth's surface. And as we were just watching as we were looking at the pictures of the superstorm, you can see some obvious and local evidence of that. But let's go back here a minute, and this is going to relate to what we're going to do in the lab. We've got mechanical weathering, which is a physical change, as we talked about, and chemical weathering, which is a chemical change. So the definitions, we did those yesterday, so it shouldn't be too tough here. Who can define mechanical weathering, and someone give us an example? Okay. A type of weathering where rock is broken into smaller pieces. And remember, we talked about this yesterday, the physical change, it's the same substance. It's still water, it's still granite, but it's just in smaller pieces. And we also discussed yesterday, it could also be things like freezing and melting, which we get a lot of around here. So smaller pieces, examples of mechanical weathering. We've had a couple already today. Yeah? So water, the ice wedging, which we'll talk about specifically, we get a lot of that here because it gets cold and then it gets sunny. Ice wedging. With water and with wind, either one of those, you put a little bit of sand in the water, in the wind, and then you get a lot more erosion. And we called that abrasion. It literally acts like sandpaper, wearing down rocks and windshields and such. Chemical weathering is a chemical change. Okay, so chemical change or chemical reaction, and I suppose in some ways the opposite of the mechanical weathering, it is no longer just the same material, it's broken down into different materials. You actually have new chemical compounds. Metamorphic rocks are a chemical change. It's not weathering, but yes, it's a chemical change. It's no longer the same substance. So what would cause chemical weathering of rocks? Examples of chemical weathering. So in chemical weathering, weathering breaks down rocks into different substances. Yeah, I suppose lightning or a meteorite hitting, there'd be enough heat and that sort of thing to actually change the substance of the rock. But there are some more common ones. Yeah, so the water itself or slightly acidic water can cause chemical changes. What happens if you leave your bicycle out in the weather? You don't ever put it in the garage. You leave it out there all winter. It gets wet, it gets dry, it gets wet, it gets dry. What happens to it? It rusts, right? So water can cause rust, and that actually is chemically changing the metal into other parts. It's changing the metal, it's oxidizing it, and that happens with a reaction between the water and the oxygen in the air. If you have a copper statue, like the Statue of Liberty that they just finished renovating, what happens to copper when it's exposed to the air and the water? It turns green. So water can cause rust. It's also known as oxidation, and that's literally breaking down the metal. You know, if something is left outside long enough, the chain on your bicycle will fall apart, the metal will rust right through. It's actually eating it away. And that's why statues like the Statue of Liberty and other things like that, they turn that nice color of kind of turquoise, bluish, but it is actually eating away at the statue at the same time. So it doesn't stay that nice copper color. So that's one example. The rain itself can be slightly acidic from pollution, which can make things wear away faster. Marble or limestone have substances in them that will react with acid, will react with water in a similar way to kind of baking soda and vinegar type thing. Obviously not that violent, but that is chemical weathering. Anyone have any other chemical weathering? Maybe caused by, plants? Yeah, but specifically, right. You might remember from last year when we talked about things like lichens and mosses, their roots literally go right onto the rock. And their roots actually produce chemicals that break down the rock. And so it actually digests the rock a little bit. So plants can literally chemically break down the rock. I'll squeeze that in down here. Plant roots. So chemical and mechanical weathering. Does that make sense to everybody? Everybody good with that? Next we have whoops, factors that affect how fast weathering occurs. Now we were just talking about some nice obvious ones, and let's see what else we got here. Put that back on top. Yes. Okay. How can the climate affect how fast weathering occurs? Okay, so a couple of different things. First of all, if it's hot, how is that going to make it go faster or slower? Not sure? What about if it's cold? And so cold, you've got freezing. And here in Colorado, we have freeze, thaw. We have a lot of sunny days here in Colorado, even in the wintertime. So it freezes at night, and then the sun shines and it melts and the water goes through the cracks in the rocks, the cracks in the streets, the cracks in the sidewalks, cracks in your windshield, and then it freezes and expands. And so freezing and thawing makes it go much faster. Where do you think erosion is going to happen faster, if it's relatively rainy or if it is a dry desert? Rainy. So if it's wet, you're going to have more of the rusting and flooding and rain. Wouldn't it take what? It depends. It's going to erode some things faster. Heat can make chemical reactions happen faster, but also in a hot, dry desert, you're going to have more wind abrasion, but you might have less of some other things. Okay, rock types. How are the rock types going to affect? What rock types are going to erode faster than others? You looked at some rocks and minerals. What do you think? What are some that would erode faster? Yeah, something that's very soft, like talc and gypsum. Yes. Good. Limestone and anything that's going to react like that. So some of the things, rock types, if it's softer or reactive, it might erode faster. And then things that are, oops, that's a D. Dense, hard, things like granite and some of the metamorphic rocks erode very slowly. And then the other example that we were just looking at a few minutes ago, what else sometimes in short amounts of time extremely accelerates erosion? You know all those pictures we were just looking at? Storms. Storms, particularly like hurricanes and floods. And yeah, you know, lightning, I don't think lightning really is a huge factor. It is a force of nature. It might knock trees down. It might, if it hits it can change like sand into glass basically, but I don't think it's a major factor in erosion just because it's infrequent.